Welcome. Let's go through the Flippin' Ferraris 1.2 and see what we can understand about inverse functions here. The first thing in driver's ed, you hear that the faster you drive, the longer it takes to stop. That makes sense. Okay. And the next part says there's a relationship between the speed of the car and the braking distance. So there's a special type of relationship. So if we're doing the Ferrari, and we're going to go with this equation, d of s equals 0.03 s squared, where d is distance and s is speed, then if you want to figure out the distance, you just plug in the speed. This is in terms of miles per hour, and the distance is in feet. Okay, so in this case, if it's 55 miles per hour, it's 0.03 times 55 squared. Okay, and for that I'd go with the calculator, or you could create a table function that would also work for 55. And let's see, I get 90.75 feet. So almost 100 feet if you're going highway speeds. Okay. Another one, the other ones were like that, is it makes sense to a lot of people if the car is moving at the same speed and goes twice as fast, would the braking be twice as far? Well, if it's 0.05 times 5 squared, or if it's 3 actually, yeah, or it's 0.03 times to 100. So there is not a 2-to-1 relationship here. This one's 25, this one's 100. So this one's going to be 4 times what this one is, as opposed to 2 times. So it's false. That's not true. And then they want a graph of the relationship between distance and speed. And you can plug in some numbers for that. It's kind of the way I would go. You can also use a graphic calculator to help come up with some figures, but some of the ones I got. So at 0, the origin is 1 point. The other one I had was 50, 75. So 50 was at 60, 75, something like that. And at 100 was at 300. Uh-oh, I'm off the grid. How about that? So this is probably 10, 20, 30, 40, 50, 60, 70, 80, 90. It's all the way up there. Okay. So, and then, you know, I could do the other ones here, but anyway, the way that looks, I'm going to just draw the curve just to kind of simulate what it is. And you can see it's half of a parabola here. All right. You can do other things, like let's say if the maximum speed is 217, what would use that to describe the mathematical features of the relationship? So the highest range is would be 1412. The highest speed would be 217. So we could do something like we could say that the domain, it's going to be either at rest at 0, but it's going to go up to 217. I used interval form here. And then the range is going to go from 0 to 1412.7. Okay, so that's my range here. And the other question is, what if they were cruising along and the braking distance was 31 feet? You could write an equation, 31 equals that. So if I divide both sides by 0.03, okay, then, and I go with my calculator on that probably, I get 1,033. So I've got 1,033 equals s squared. So s is going to be the square root of 1,033. And that is, I get about about 32. So S is approximately 32 miles per hour. Okay, so does that make sense? 31-foot skid, 32 miles per hour. Seems like it does. And then there's another piece of it is they look at the case with police officers given a certain D. What's the S value? And for that one, I'd probably go with the table. And I'd probably go with, gosh, let's say my speed was 0, and let's say 50, and let's say 100. Okay. And then if I go to my table, and I'm doing on my my graph calculator here. Okay. Let me try it again. So I've got, what does it happen with the speed of 50? And when I actually can get this from up here, right? I don't need to calculate it again. So at 50, I got 75 here. So when the speed is 50, it was 75 feet. So on this table, if it would be 75 feet gives me a speed of 50. And then on the other one I did was at a speed of 100, it was actually close to 300. So I could say my distance of 300 for 100. And then to write an equation, this would be S of D. Okay, so given the distance, what is the speed? All right, and what I could do for that is I can go with the original equation, which is D equals 0.03 S squared. I can divide by 0.03, and then I can say that D over 0.03 is equal to S squared. Therefore, S is the square root of D over 0.03. Okay, and that's